Hello everyone and welcome to the Enhancing Clinical Practice and Outcomes stream of the SNOMED CT Expo 2021. My name is Kathy Richardson and I'm a Senior Terminologist at SNOMED International. I'll be moderating today's session. Please use the live Q&A in your AirTouch device to type your questions to the presenter. All questions will be answered at the conclusion of the presentation. I'm now pleased to introduce John Gottschalk and Aileen De La Pena from the Australian Digital Health Agency, who will be presenting experience with a proof of concept application for classifying medications and medical conditions to determine medication adherence in chronic medical conditions using SNOMED CT-AU. Over to you, John.
Okay, thank you. So we worked on a proof of concept application to look at the feasibility of using a mixture of data, both coded and text-based, and from a variety of sources, to examine a person's or people's chronic medical conditions, the sort of medications they're taking, and to determine how well they were adhering, like was there any evidence of them taking the medications for those chronic medical conditions. This was part of a larger project to improve medicine safety. The information that was used for this work came from a variety of places. Some of it authored by or created by general practitioners. Some of it came from hospitals, such as discharge summaries. There was prescription and dispense information, and there was other information included as well. We particularly wanted to look at the problem diagnosis information, the medications data, and the clinical indications, which is also referred to as reasons for prescribing. That is, what is the reason for prescribing a medicine to a person? The information contained a mixture of text and coded data. We found that approximately 41% of the data was coded, which is more than I expected, so that was good. And 59% of the data was text only. So we had to cope with text-only data and coded data. The tools that we used was a terminology server, which was the Onto server product from the Australian CSIRO. One of the key features of that was its ability to flexibly map text to codes. It provides a file interface, and we developed an analysis tool to access the terminology server using its file interface. And we made extensive use of SNOMED expression constraint languages, or ECL. The value domains that were used in this work for medical conditions was clinical findings and procedures. And it may seem odd that we use procedures for medical conditions, but I'll explain that later. The value domains for the medications were trade products and medicinal products. That's generic products. The medicines coding is done using the Australian Medicines Terminology, also just called AMT, which is an Australian extension to SNOMED CT. For SNOMED CT, we used the clinical findings and procedures coding. And we had a tool, as I mentioned, which we ran through iteratively to get the final result. When we found data that was coded, if the coding system that was used to code the data was SNOMED CT or the Australian extension to that, then if the codes were in the required value domain, then they could be used. We also allowed for the possibility that there was inactive codes or historical codes. And we coded for that by finding the associated active codes using the association reference sets. If the coding system was not SNOMED CT, but we had a mapping to SNOMED CT, then we used our map to convert the code to a SNOMED CT code. If the coding system was used that wasn't SNOMED CT and we had no mapping, then we just couldn't use the code. So what we used was the text associated with the code. There'll always be a text, associated with the code. So we used the text as if the code didn't exist. And then for that scenario, and also for concepts that were just text-based, there was no code, then this is the process that we followed. We would do when I say we, the software would do a preliminary assessment to determine if coding could even be attempted. An example of one of the assessment rules was, does the text consist of a few words or is it prose? That is, does it consist of, paragraphs and multiple pages or numbered and unnumbered lists? So we would reject some text if it couldn't be coded. If the text could be coded according to those rules, then we would transform the text using some transformations. And one of the transformations used knowledge of editorial rules. For example, for the Australian medicines terminology, milligram is never present in the preferred term or synonymous term. It's always present using the abbreviation MG. EC tab is always present as an enteric tablet. So we use those editorial rules to map the text to a format that where the Onto server, the terminology server, would be more likely to find a code. And we did other transformations as well. Then once we got the transformed text, we would send that across to the terminology server and ask it for codes in the applicable value domain. We would also allow it to search for historical inactive codes as well. So here's an example, a fairly simple example. If we had a concept that was diuretic-induced hypokalemia, that would be sent across to the terminology server, and it would come back with that code just mentioned there, which actually has the preferred term drug-induced hypokalemia. So it used some flexible matching to find out that code corresponded to the text that we gave to it. If there was multiple codes returned by the terminology server, then our analysis tool, we compare the preferred terms with the text that we had to select the best matching one. If at the end of the day there was still multiple codes for a concept, then that was okay, because we weren't really fussed about using just one code for a concept, because what we want is the classification for the concept. And in almost all cases, if there was multiple codes, they would come under one classification. So procedures, and why do we use procedures? Well, some of the text that we examined was actually written as a procedure. For example, clinical indications were sometimes written as a procedure. But what we did was that we would use the tool to use the relationships recorded in SNOMED that map procedures to clinical findings. So, for example, the procedure, management of patient-controlled analgesia, is associated with a clinical finding of pain. Now, we were careful to remove evaluation procedures, such as laboratory tests, because just because you're being tested for a medical condition doesn't mean you actually have that medical condition. So we would do that screening before we map the procedures to clinical findings. Now, applying these processes resulted in SNOMED codes for medical conditions and the AMT extension of SNOMED for medications. So the next step was to derive the classifications. The biggest challenge for this was to classify the medications. And we tried two different approaches. One was to classify the medicines using the substances in the medicines and the substance hierarchy in SNOMED. And the other approach was to use a mapping that we had to the World Health Organization anatomical therapeutic chemical classification system. Now I'm going to hand over to Eileen now to talk about these classifications.
Thanks, John. So some of you may be familiar with the Australian medicines terminology, and at the heart of this model are what we call the 7 boxes, which describe the medicines at different levels of detail. So on the left, we have the abstract or the generic representations, and on the right, we have the trade products or branded representations. And this slide describes the brand Panadeine. Now, there's a lot of information on this slide, but the important point is that you have access to all of the information held within the model, no matter which concept you are starting with. And this is due to the relationships between the concepts. And I'll talk about this more on the next slide. So on the left here is the Container Trade Product Pack or CTPP concept for Panadeine tablet, 24 blister pack. And one of its defining attributes that I've highlighted is the has-TP-UU relationship, which links it to the TP-UU of Panadine tablet, which is the diagram on the right-hand side. And from there, you can get access to substances. And there are a couple to choose from. And for this proof of concept, we use the intended active ingredient. And I'll talk about why substances were used on the next slide. So the AMT was developed as an independent module from SNOMED CT core, and that meant that the product concepts had to be defined by the concepts authored within the Australian extension. There are a couple of limitations with this. So one is that the SNOMED core content is duplicated within the Australian medicines terminology, and this includes substances. The other limitation is that the AMT stops at the product concepts, but grouper concepts are useful for prescribing workflows and decision support. These groupers were only present in the substance hierarchy at the time of developing the AMT, so we created a map between AMT substance and SNOMED substance to help navigate to these grouper concepts and enable richer analytics. So here is a representation of the substances in Panadine tablet, which are codeine and paracetamol. And to the left are all the possible groupers or classifications we could choose from. So typically you would identify the appropriate groupers and then define additional rules to include or exclude certain descendants. And this process was the same for medical conditions. So for this study, we were mostly interested in therapeutic role groupers, but also disposition groupers, and these describe mechanism of action because they are commonly known and understood. Now here, both substances are linked to analgesic, which describes a therapeutic role and is a good candidate as a grouper. There is ongoing work by SNOMED International to move these therapeutic role groupers to the pharmaceutical biologic product hierarchy because they're more correctly placed there, as the therapeutic role of a product depends very much on its formulation as a product. And the complexity with using substances for this analysis is further highlighted in this example where Panadine as a product contains two substances and could therefore be counted twice under different categories. So this wasn't an issue for this proof of concept, but it is not ideal. And so I will talk about another approach on the next slide. So due to the complexity of using SNOMED, we also use the WHO ATC classification system in parallel to see whether there was a difference in process or output. So the ATC system was designed for drug utilization research and is monohierarchical in structure. And this traditionally supports statistical reporting. The principles of the classification are medicines are classified according to their main therapeutic use, and there is only one ATC code for each route of administration. And so this means a substance can have more than one ATC code for clearly different purposes or therapeutic uses. Combination or multi-ingredient products are often represented with a single code, such as here, there is a single code for codeine and paracetamol. However, similar to SNOMED, there are a few levels of groupers, looking at the top of that screenshot, and therapeutic role can be described in the second, third, or fourth level. So there is still a curation process to go through, even though the structure of ATC codes are simpler. So for this proof of concept, we used a mapping available from a dataset published by the Pharmaceutical Benefits Scheme, and that allowed us to obtain an ATC code for a given AMT code. So next slide, please. So let's talk a little bit more about these categories. As a starting point, we use the Chronic Health Conditions Report published by the Australian Bureau of Statistics to give us a short list of the chronic health conditions. And then we accessed resources about treatments for these conditions from resources such as NPS Medicine Wise or Health Direct or Clinical Peak Associations to have a short list of medications to look for, but then also be able to map the medications back to a chronic condition. Now, from these lists, we had to define the appropriate SNOMED codes, and then we also created some ECL rules that were imported into the tool to capture the descendants. And then, as you can imagine from these starting lists, there were many codes that were not grouped under these original codes. So then we had to refine the process. So it was more and more data was analyzed. There was more data coming through, and therefore we had to look at, define suitable categories for them. At the beginning, these uncategorized lists were large, but they became smaller and smaller as more clinical documents were analyzed. Next slide. So here is one of the chronic conditions we looked at, gastroesophageal reflux disease, or GORD, and we mapped antacids, H2 receptor antagonists, and proton pump inhibitors, or PPIs, based on our source material. In the table are the SNOMED codes that we used for the analysis, and the code for disorder is straightforward, but there were a few candidates on the medicine side. So we went with the substance concepts because that was the destination from the AMT substance map. And in the future, we would look to use concepts from the product hierarchy and possibly even the procedure hierarchy, where it refers to a regime or therapy. The next slide. The proof of concept worked quite well, but there are a few challenges with this process. So at the top here, I've called out the manual nature of this task. Essentially, every time a new set of clinical documents were fed into the tool, had to reassess the categories and their definitions to work out whether to add, delete, or merge some of the categories. This wasn't built in as part of the tool, and we can improve on this part of the process. However, as I said, we did get to a point where there were less and less uncategorized concepts that we had to reassess. The rest of the slides, the points on this slide, would be familiar to anyone using SNOMED for aggregation and therefore not unique to this proof of concept. Some of the rules were quite complex, and this is due to relationships between concepts. For example, low back pain is a subtype of back pain, but because both were called out in the chronic conditions report, we decided to keep them separate. Also, some categories were not available in SNOMED, and this affected the medications, such as blood glucose lowering agent. So these had to be manually created and linked to individual substances. Also, we found that some codes were not able to be characterized at all or fell out of scope for this project. For example, a general finding or an event such as a fall. These did not describe medical conditions. And specifically, one interesting example was phenadrine citrate was coming up as both an anti-Parkinsonian agent and a centrally acting muscle relaxant. And we did a bit of research, and it seems that the substance was used as a treatment for Parkinson's disease, but is no longer routinely used that way. So just something to be aware of, that historical information may be represented in SNOMED. Next slide. And so I'd like to touch on the findings specifically around the SNOMED substance groupers, as we found they were not fit for purpose for this study. Apart from the lack of some of the groupers that we wanted to use, the main difficulty was assigning a therapeutic use based on substance only, since use is very much dependent on the product itself. So you would never know whether aspirin was used as an antithrombotic or for pain relief without information about the strength. And this problem is compounded with multi-ingredient products, as it doesn't make sense to abstract them to the individual substance. So therapeutic role groupers in the product hierarchy are therefore better candidates for this type of analysis because they clearly identify medicine's use, but they require some improvements for usability. So the list of groupers in the hierarchy at this stage is not extensive enough, and perhaps the bigger barrier is that where a grouper does exist, it doesn't contain all of the products expected to be grouped under it. So it would be helpful if there was a roadmap to know the scope of work remaining and timeframes for users who are interested in these types of concepts. So adjacent to that is that the AMT itself is not yet mapped to the product hierarchy. There was some initial analysis done regarding the modeling, and we have been performing some activities to prepare for integration, such as simplifying dose forms, but we are still some way off from actual integration. So regarding the WHO ATC classification groupers, we found it produced similar results to SNOMED substance groupers. And given that it was much easier to work with and is already based on product, we would recommend using this strategy for future iterations of this work. And the mapping that we had was a good starting point, but was only a subset of medications available in Australia. So further work is required to define the scope and rules for this mapping. And I'll hand over to John now to conclude the presentation.
Thanks, Eileen. About the inactive codes, we didn't expect to find many because we were trying to look at current information and we didn't find very many inactive codes. Something that was interesting was that most clinical indications described a medical condition quite well. And out of those that weren't a medical condition, they were quite often a procedure, and some of those could be used to derive a medical condition. We did look at some findings that was used to verify that this proof of concept was working as expected. It showed, for example, the unsurprising finding that chronic medical conditions increase with age. And we found that there was associated medication for most chronic medical conditions. Not all of them, but we didn't expect to have medicines for all of them. We found that the text transformation that was done prior to coding would be better if it was done by the terminology server. That would be a useful improvement. But the results were sufficient to prove the feasibility of the analysis. Clearly, the use of codes rather than text reduces processing time, so it's useful for the data to be more coded than what we had. The next step for us is to do a quantitative analysis to work out timings of the process, the accuracy of the process, and we started to do that already, and we'll hope to have some that concluded a bit later this year. So that's it for the presentation. Thank you.
Thank you, John and Aileen, for the presentation. Can I ask that the attendees give us a few moments now to switch over from the pre-recorded content so that John and Aileen can answer your questions live for the questions that have been submitted. And just a reminder that this session will be available for 3 months after the event on the platform. Thank you. Okay, we're live now. So thank you very much for your presentation, John and Aileen. It's great. Now, for those who are attending the session now, if you look at your air support device on the bottom right of your screen, and if I put my hand up, it'll show the other side, so I'll keep it down. And you can put your questions into there so that we can ask them during this session. Now, to get us started, you mentioned having text and code and the differences between the two. Now, what did you find with the processing time? Sort of how much more was it when you were using the text?
Well, we haven't done any timings yet. The processing codes, doing the analytics when you've got codes is considerably faster. Because when you've got text, you've got to process, do a lot of pre-processing before you send it across to the terminology server. Then the terminology server takes a while to find the code, and you don't need to do any of that if you've got a code already. We don't have timings yet, but it is a significant difference. That's what we know.
Okay. So you mentioned like needing to use text as we've talked about there. Was there any request submissions that eventuated out of this work? So you were using like chronic medical conditions. So if you found conditions were missing, did you end up submitting them through?
Well, we have actually. We've submitted a number of things through at various times. Most of the things that we've submitted are actually in the area of adverse reaction substances.
Okay.
Which was a bit unrelated to this project, but we found some new things there. So we have submitted them. So we have started to increase the number of terms in SNOMED as a result of our work.
Okay, so that was in your national extension or the international?
That's in the national extension.
Okay.
It's interesting, some of the extensions are things that you might expect with Australia, such as adverse reactions to Vegemite and kiwi fruit.
For those outside Australia, you'll have to look up Vegemite. And I'm not sure what the other name for kiwi fruit is, but I think it's called something else in other countries. So the AMT model, how well does the AMT model align with the international medicinal product model?
Oh, that's a big question. So as I said, we had done some analysis on what how well the product classes are equivalent. There is a medicinal product concept in the international model, and that aligns quite nicely with the AMT medicinal product. But then when you get down to, I think, the medicinal product form and the clinical drug, they don't align as well with our unit of use, for example. There's just slight differences in how these products are defined. So yeah, there's still more analysis and more effort that we need to do to prepare for integration.
Okay. So is there any questions from the audience?
While we wait, I've got a bit of other information from work
Okay.
we've done since that presentation was recorded. And that is, we've been analysing the clinical indications that accompany medicines. Clinical indications, which is the reason why a person's been prescribed a medicine, also called reason for prescribe. So that's always been provided to us in our health records as text. But we found out that more than 95% of the time, the clinical indication is a very good description of a medical problem. So clinical indication can also be a procedure or an event or a few other things, but it's almost entirely a good description of a medical problem.
Okay. Well, thank you. Well, with that, I don't have any further questions. So I might thank you both, John and Eileen, for presenting today. And I hope that everybody here enjoys the session. If you think of questions after the session, please feel free to contact these guys via the program. So enjoy. Thank you.
Thank you.
Right.